Starting video. How do we go through and approach this? So really what this is asking you to do is to try to evaluate patterns within chemistry. So what patterns do we need to be looking at? So first, let's look at the given information: sodium chloride, magnesium chloride, aluminum chloride. So we're given those three substances all as chlorides. Okay, so that's staying consistent. So what is changing is that first part. Okay, that first part would be sodium, magnesium, and aluminum. We'll look at a periodic table in a sec as the background. I don't think I have anything suspicious back there, so we should be okay with that. The question itself asks you for the formula for gallium chloride. So we're looking at gallium, again, that first part, and then interestingly, again, the chloride is staying constant. So something about the information here needs to be tied between sodium, magnesium, aluminum, and gallium. There has to be some pattern associated with those that we could evaluate, because the chloride is staying constant through all of those. So I'll try and remember those. And I don't think I need to remember them. I might just be able to pull it down. So we had, if we run that again, there's our gallium, which the question was asking about. We've got gallium, we've got magnesium, sodium, and aluminum. And I would actually argue that this question is easier than it could be. I think it could be made much more difficult, and we'll talk about that here in a second. So what we did was read through the question, look for the patterns, and say where did things stay constant, where did things change, and then we went to the only place that we really have access to that could show all of these pieces. That's the periodic table. So remember, you're a chemist, look to the periodic table, and when we do that, what kind of stands out as a potential pattern that you might try and take advantage of? Gallium and aluminum are in the same column. If we think back to our periodic table organizations and labels, the name given to a column is known as a group or a family. And that name has to do with the fact that they react similarly. You interact with the world based off of how you were raised from your family. So that interaction is largely driven through or is pretty much only characteristically driven through the column. Which means if the formula for the aluminum chloride is AlCl3, I would expect gallium to interact with chlorine the same way as aluminum does. So my answer should be gallium 1Cl3. And there we go. There's an answer. Okay. The way this question is formatted, I would argue, is a bad format, because if you know enough to move to the periodic table to try and look for patterns, there's really only one that makes sense, and that's the one we've identified in red. So how could we make this potentially more challenging? Well, instead of giving you sodium, what I would argue would be a better question would be to give you, say, zinc. Okay? Now it becomes a much more difficult question, because we see two ways that we could establish relationships. We could look to see that gallium and zinc are in the same row, or we could say aluminum and gallium are in the same column. And so we would actually have to know a little bit more content knowledge to recognize that columns or families are where we get chemical patterns, and we don't get those chemical patterns across a row. And so by changing one of the given pieces of information to be zinc, we've now upped the level of difficulty behind the question. Okay? So what you now have are two insights on this. Number one, how to answer the question as asked. Number two, recognition that your instructor who's writing the exam question for your final thinks that it was written poorly and has just told you how it would be changed. Pretty useful insight. And then 3, we could also just say, is there a way, just looking at the answer choices, that we could try and process our way through this? Okay. The reason they gave you this information was probably so that you would have to use it. If we go through and look at our patterns, if we followed sodium chloride, we'd be gallium chloride. If we followed magnesium chloride, MgCl2. The aluminum chloride, start to write the aluminum, Cl3. Okay? If we go through and try and match these, GaCl matches, GaCl2 matches, GaCl3 matches. What evidence would ever allow you to make an assignment about Ga3Cl or Ga2Cl? Okay. There's no patterning behind the given information that would allow either of those to make sense. So if you knew nothing else, those should get eliminated as answer choices, and you'd now be down to a 33% chance of getting the answer right with guessing, or which is better than the 20% that you started at. Okay, so you get 3 potential insights into that question. Because I've got the screen set up this way, I can't see if you're chatting anything, so I'll give you a second if you wanted to comment something about what's written there. When looking at this question, because it's a chemistry class, we should be concerned kind of about our chemical formulas. So when we're looking at our chemical reactions. So one of the first things that we should kind of trigger off of is note that we have a chemical equation with these lines floating out in front. Those lines are supposed to represent the coefficients that would go with this. Because we're looking at a chemistry class, we're probably going to be doing something with a chemical equation, and a chemical equation is only useful if it is balanced. So an immediate first place to start this question, and because it's online, all digitally done, would be immediately trying to balance it out. So you might just start by writing, okay? And I know I could draw in over the top, but just to give you an idea. Commit right away, aluminum plus HCl. I'm seeing as I'm doing this that I'm going to need at least 2 hydrogens, go across, aluminum Cl3, and that's starting to set up alarm bells. Something weird is going on here. So I may actually backtrack out of that too. So I've got it rewritten. My aluminum is matched, but my chlorines are all sorts of weird. Best way to think about doing that would be I'd need a 3 here, but now I would have 3 hydrogens. And 2 hydrogens, and that doesn't balance. Lowest common multiple is 6. I can make it a 6 if I put a 3 here, but then that means on the other side, to make that a 6, I would need to multiply by 2. Okay, so that goes up to 6. Now I can double back and check chlorine. Chlorine's actually at 6 on this side. The other side it's at 3. For it to become 6, I have to multiply by 2. I can now go back and look at my aluminum. I need the 2 there, and now we'd have it balanced. Okay, now that I have a proper balanced equation, it's quite possible that I didn't need a balanced equation to answer the question. The odds that that's actually true are pretty slim. If we gave you an equation with the lines in front, you probably need to consider balancing it, particularly if you're saying numbers as answer choices. So now let's go back and actually look a little bit closer at the question. Mass of aluminum, so I have a question mark. So this is one of the reasons why the equation can be nice. I can format things underneath. To release 1 gram of hydrogen gas. So I could write my 1 gram of hydrogen over there on the product side. So that question mark, I do know some information. I'm going to know it's grams, and I know it's aluminum. So what I'm looking at trying to do is run some kind of conversion between these. In that conversion, the substance changes. The only way to get a substance change is through a balanced chemical equation. Okay, so we could now kind of launch into our solving process of our overall solve out. What were we looking for? Grams of aluminum. Okay, we were given 1.00 grams of hydrogen over 1, because it's a single piece of information. I would need to get rid of the hydrogen and bring aluminum in. Based off of what I remember of my videos, I think I have this one in purple whenever it's involving a balanced chemical equation. The units, or the measurement unit associated from a balanced chemical equation, is typically moles. It's the easiest one to work with. I can now pull the coefficients from my equation. There's a 2 in front of the aluminum and there's a 3 in front of the hydrogen. Okay, so this would be great. It allows me to do a substance conversion. The big problem here is that moles is not the measurement that I currently have. So I'm going to have to do another conversion. In that next conversion, what do I want to have happen? Well, I don't want moles of hydrogen. I did nothing to my grams of hydrogen, so it might be nice to get rid of that too. Is there a way to relate the grams and moles for an individual substance? That comes from the periodic table. 2.02 grams of hydrogen is 1 mole of hydrogen. Why is it 2.02? There's 2 hydrogens and hydrogen has a mass of 1.01. If we look at our units now, the moles of hydrogen cancel, the grams of hydrogen do a long distance cancel. Do it this way, slightly different colors. The unit we'd be left with would be moles of aluminum. I don't want moles of aluminum, I want grams of aluminum. So I need to do another conversion. Moles of aluminum needs to be in the denominator. Grams of aluminum needs to appear in the numerator. Where do I find the relationship between grams and moles? That again is the periodic table. I believe it's 26.98 for aluminum. I honestly don't remember exactly, but I think that's right. But I would pull that from the periodic table. What happens? My moles of aluminum cancel. I would now have grams of aluminum, and I can go through and get my final answer. Okay, and that was done 6 minutes, and so that's an explanation of walking through that in 6 minutes. What I see when people go through to try and attempt this kind of question is they just don't know where to start. We gave you a starting point, chemical equation. Get the chemical equation down. Start converting that information into something that you can manipulate and use. Okay, so we started with the chemical equation. We balanced it. Okay, we then wrote down the information from the question, what we wanted, where we ended. And then we had to evaluate what was going on with the units through that process. Okay, so that was identifying the substance change. Once we had the substance change, we then started into our actual conversion process. Okay, doing it in this particular order is great, but really the order doesn't matter. You could start at any one piece. It's whichever one kind of jumps out at you. All 3 of these or 4 of these pieces need to be identified at some point through it. Because I can't see your comments if you're typing anything, I'm going to give you a second to chime in with a question audio-wise, and if I don't hear anything, then I'm just going to delete the screen and hope I don't see a question floating under there. Real quickly, so if you wanted to review that work, all of the work as written, it's 14 minutes.